So in this video, I'm going to go through this example problem, and I'm going to start by reviewing the equation of conservation of mass. So remember that in general, we're looking at the change in storage with respect to time is going to be equal to the inputs into our control volume minus our outputs. So when we think back to the hydraulic cycle or the water cycle, we are going to go through what all could be inputs versus outputs. So under inputs, I'm going to put things like precipitation, because that can be an input into the watershed. I'm going to put stream flow, because that could be an input into a watershed. And then under outputs, I'm going to put evaporation, transpiration. That is always a loss. I am also going to put stream flow, because you can have flow out of a watershed in a stream. And then lastly, infiltration, which is the water that we lose into groundwater. Okay, so looking back at this example problem, we're going to look for clues here on what we're going to use for our control volume as well as our input and output. So this 20,000 acre watershed sounds important, as does river outflow of 11 CFS. And then we have information here about evapotranspiration and then precipitation. And we know that there is no loss to groundwater and that storage change is negligible. Okay, so this watershed, that's our control volume. We know that this river outflow is an outflow or a loss. So is the evapotranspiration. The precipitation is our inflow. And then we know from this that ds dt is going to be equal to 0. Okay, so we're going to come down here and solve the equation ds dt equals 0. And that's going to be equal to the precipitation that falls minus the evapotranspiration minus that outflow Q. We can rewrite this knowing that the evapotranspiration is 60% of the rainfall, the precipitation, so we're going to write that as P minus 0.6 P minus Q is equal to 0. We're going to go ahead and use this hint now where we convert the discharge to a depth. Okay, so what that exactly means is that we're going to take that 11 cubic feet per second. Remember, CFS is the discharge of flow rate, which is a volume of water over some time. And we're going to instead see what depth of water that would be if it was applied over the entire watershed. Okay, so we're going to convert this Q to depth for an entire year. So we start with that 11 cubic feet per second, and we're going to convert from seconds to years. So we know there's 3,600 seconds per hour, 24 hours per day, and then in 365 days per year. Okay, and if we do this math, you will get that 11 cubic feet per second is the same as 3.47 times 10 to the 8th cubic feet per year. Okay, so this whole watershed the outflow from this watershed is 3.47 times 10 to the 8th cubic feet per year. So we know that this falls over an area of 20,000 acres. We're going to convert that to cubic feet by using this conversion factor that was given. We know that 43,560 square feet, that should be squared feet, per acre, which leads us to a watershed area of 8.7 times 10 to the 8th square feet. Okay, so I am going to take that volume of 3.47 times 10 to the 8th cubic feet and divide that by the area of 8.71 times 10 to the 8th square feet, which is going to be equal to 0.40 feet per year. Okay, so this 11 CFS is the same as if you had 0.4 foot of water for the entire year. This is our Q out. This is equal to 4.8 inches per year, if we want to convert that to inches. Okay, so now we're going to go back to our equation, our dSTT equals 0 equation, because we have a little bit more information here that we can use. So let's see here. All right, so let's take this equation, bring it down here, and we know now that 0 is equal to P, which is our unknown in this whole thing, minus 0.6 P minus Q. And we know our Q, right? So we can rewrite this as 0.4 P. This is all going to be equal to 0 here. Minus 4.8 inches. So we can solve for P equal to 12 inches per year. And that is our answer. So what does this mean exactly? Let's scroll back over up here to our problem statement where it asks us to find the estimate the annual precipitation depth over the whole watershed. So we found that based on what we know, that we lose 60% of our rainfall to evapotranspiration, and that there's an annual average discharge of 11 cubic feet per second out of the watershed. We can use this information to estimate that the amount of rain that falls over the year is 12 inches per year. So take this opportunity just to look online, see the average rainfall in the area where you live, so you can see what 12 inches per year means to what you know about rainfall, right? As an example, in San Jose, in Santa Clara, the average rainfall per year is about 17 inches. But over the whole nation, the average rainfall per year is closer to 36 inches per year. So this 12 inches per year might be something that you would see maybe in Southern California. They usually get a little bit less than us. But it's not something that you would expect if you live somewhere like on the East Coast or Hawaii. So it's really good to just keep these numbers in mind and in context to something you might know. Hopefully solving this problem will help you with that first problem set. So go ahead and give it a try, and we'll have a problem solving session via Zoom next week.